right, good morning. Welcome back to the TS class. Hopefully last class went really well for you. We're going to continue and pick up from there. So the plan for the day is to go over the assignment that I gave you yesterday, and then we have a whole bunch of material to cover together for the day, and then you'll have some assignments and whatnot. Yesterday I posted the notes at about 2 o'clock, so you should have had access to the notes as of then. We will continue to do this every day. At the end of today's class, I'm going to explain how tomorrow works and what the expectations are, but do not forget that you're in school tomorrow, no video, no live. So if there are any questions, any online issues, please send us an email or call the summer school. You have tons of different resources to help to make sure that everything runs smoothly here, so make sure you're doing that. Other than that, we'll just work on the math together. So like I said, I'm going to start with the assignment that was posted on the Google Docs yesterday. We'll go over those problems. I'll give you individual feedback probably either this afternoon or tomorrow afternoon, so you can know how you're doing individually. And we'll be doing the same thing today and tomorrow and so on. Once that is done, I'll take questions from the handout. So you had the handout that was posted yesterday to work on. The solutions were posted this morning, so you might have had a chance to look it over. You might not have, that's okay. If not, we can go over some of those problems together too, whichever ones you choose. If you have a problem you want to go over, just speak up or type it in the chat. The last post that I posted, if you notice, is, no? No? Sorry guys, just 1 second.
Please don't touch my Hi, everyone.
Sorry guys, we're just trying to get a couple of people last minute in. They're having some technical difficulties, so we're just going to sort this out for a minute or two, and then I'll be with you to pick it up in 1 quick second. So just be patient with me. Thanks.
Hey guys, how's your days?
Great, sorry for the delay. We are back. Okay, so not sure where I was, but that's all right. So,
oh wait a minute.
Thank God.
Am I muted?
okay, so just make sure before, again, when we get started, make sure that you're all muted so that there's not a shift in the focus all the time and that I don't cut in and out. Okay, so like I said, we're gonna go over some problems today. We'll go over the assignment, then we'll go over the handout, any questions that you had. Like I said, if you look at the stream, I'll just screen share here. Share, fantastic. So here in the stream, we have yesterday, the notes were posted, the handouts, handout was posted, the solution for yesterday's handout was also posted. So make sure you're checking those out. Everything else will be posted. For some reason you cannot talk in the Google Hangout chat. There's this link there. Here it says if for some reason you cannot chat. I am looking at the chat right now, so it's another way that you can ask questions at any given time. Okay, so today we will start off with reviewing the assignment. So this was your assignment here. Just open this up. Yesterday, so like I said, I will be providing each of you with individual feedback over the next day or so for all of these assignments, but in the meantime, I do want to go over these problems just to make sure that we're all on the same page and understanding what's happening here. So we have these problems. So problem number 1 was 4x squared root of 12x, all bracketed, 5x cubed, 6x to the 5. So when we do this problem, we put our coefficients together. So we have 4x squared times 5x cubed. Then we put everything that's under a root under together. So we have 12, 6x, and the x to the 5. Now we want to start putting things together with the coefficients. So if I put the 4 and the 5 together, I get 20. If I put the x squared and the x cubed together, I get x to the 5. Now again, with the roots, what we want to be doing is finding things that we can pull out of there. So here, if I break 12, I have 4 and I have 3. For the 6, I have a 3 and a 2. I put these x's together, because if I put them together, I just need even number. Now, what can be pulled out of this? So we can pull out the 4. So here we have the 20 x to the 5. 4 gets pulled out as a 2 because the square root of 4 is 2. Here, the 3 and the 3 get pulled out. One single 3. And the x gets pulled out as x to the 3 because we take the 6 and divide by 3. What is left in the root? Just a 2. We then put our numbers together. So we have 20 times 2 times 3, which is 120. X to the 5, x to the 3 gives me x to the 8. And then we have the root of 2. Any questions on that? So let's take a look at one. We have 45x cubed, 32x3 divided by 18x squared. All right. So here we go. Small number. So there's a question that says, how did I find the small numbers? I'm assuming, correct me if I'm wrong, you mean the 4, 3, and 2. So I got the 4 and the 3 because those are the factors of 12. So 4 times 3 gives me 12. And here, 6 is broken up to 3 times 2. Okay, fantastic. All right. So let's do this one. So there are 2 different ways to approach this problem. So I'm going to approach it one way, and then if someone wants to try a different way, let me know. So what I'm going to do is I'm just going to pull out whatever I can pull out from the roots right away. Well, 32 can be written as 4 and 4 and 2, and the x can be written as x and x squared. Yep. 18x squared, we keep it written as 4 times 2 times x 4. You have to forgive me. I think I'm still getting used to my writing tablet here, so it gets a little crooked at times. So what can I pull out here? I can pull out this 4, and this x squared. If you copy my beginning, 4 gets pulled out as a 2. This 4 gets pulled out as a 2. X squared gets pulled out as just an x. We are left with 2 and x, but I'm going to separate those just for a second here. All right, we have the 18x squared. This 4 gets pulled out as a 2. The x4 gets pulled out as x squared, and I'm left with a 2. Now, essentially, you want to cancel things out as much as possible, put things together in the simplest term possible. So first of all, 45 times 2 times 2 is going to give me 180. X cubed and x gives me x to the 4. This root of 2 and this root of 2 cancels out. So I'm just left with the root of x. On the bottom, I have 36x to the 4. Well, this x to the 4 cancels with this x to the 4. 180 cancels with the 36 to give me 5 and 1. Left with 5 root of x. Answer you may have gotten could have been this one. Either one of those are completely acceptable, okay? So you just have to make sure. Why is it 2x? So I have a question that was asked in an exam. If you have to take some numbers out of the root but you don't, how many marks will be taken off? So this depends on where you get this problem, okay? So if you get a radical problem in a part A, so in a multiple choice question, if you don't pull it out completely, you may not find your answer. In a part B question, this is the worst case scenario, because in a part B question, if you don't reduce it completely, if they give you something and they say reduce it or cancel, simplify, whatever, and you don't do it completely, you won't get the points. Because in a part B question, like you found out throughout the year, part B questions are all or nothing. Okay, so if you don't pull it out properly and your answer isn't completely simplified, you won't get the marks. So in this case, for instance, this is the answer that they would be accepting, and that would be it. In a part C question, if you have a part of it that's a radical problem, it depends on how important the radical was in that problem. So you know with part C questions, there are a whole bunch of different steps. So depending on what steps you do correctly and which steps you don't, that'll determine how many points you're losing. But if you don't simplify it all the way, you'll get the majority of the marks there for the most part. So worst case scenario is you get it in a part B. If you get it in a part B, make sure for all of the stuff that you're super careful, especially for this, it has to be reduced completely. All right, so I was asked to go over some of the handout that you had yesterday. Actually, this will be better. Need to know which questions that you would like to go over. Obviously, we can't go over every single problem on this handout, otherwise it would take a whole 2 hours. But if you have a couple of questions that you want to go over, just let me know so you can speak up or type it in the chat. To answer your question, these two 4s came out as a 2 because the square root of 4 is a 2, and the square root of 4 is a 2. All right, so we have all these problems, so anything that you want to do here, more pertaining to the radical ones, let me know. I'll give you a minute to just take a quick look over it. Otherwise, we'll be moving on. Okay, so I have number 20 right in front of me. If this is not the number 20 that you were referring to, let me know. All right, we're in red. So in this case, okay, we have to actually done adding subtracting, so I'm going to save this for so we can be very clear when we talk about adding subtracting. Number 6, 4, 7, 10. For 6, this case is put them together. Okay. Ooh. So for number 6, all you can do is just put this under one root, okay? So we have x and we have 5. So this was just testing your knowledge of could you use this property. Number 4. Or this is a case where you want to break it up as much as possible. Wrong page. The first page. Okay. Okay, number 4 on the first page. Basically, you're just putting all of these together. Okay. 5 to the 10, 5 to the 5. We subtract, so 10 minus 5 gives me 5 to the 5. 6 and negative 4 gives me 6 minus negative 4, which gives me a to the 10. And 6 minus 6 is 0, so these just cancel out. Away. Number 6. So for this one, this exponent distributes to every term within this bracket. Okay. So you get 5 to the 4, to the 4, y to the 4, and z to the 4. Power of a power means multiply each of the exponents. Okay. We just do 4 times 1, which is 4. Number 7, here's the same idea. So we're doing power of a power, which means I'm going to take this and I'm going to multiply with each of the existing exponents. 5 times 3 gives me 15. Negative 2 times 3 gives me negative 6. Times 3 gives me 12. But I can't have exponents, so I move it to the bottom and it becomes positive. Number 10 is you're changing it so that you have negative exponents. So anything that has a negative exponent is not happy where it is. 2 has to go to the bottom. It becomes positive. X stays. Y stays. And the Z goes to the top. Okay. Number 15. Okay. Put all of this under one root. So I have 2 times a to the 3 times b to the 3 times b times c times c to the 3. Now I'm going to rewrite it that way. Or because like I said, we want positive exponents on our variables. 4. Now, we're going to take everything else that you can, okay? So the 2 2's come out as 1. The 4 comes out as a to the 2. The b to the 4 comes out as b to the 2. The 4 comes out as c to the 2. All right. Perfect. Now the last one. Question 5 in part 1, 2, 3. Question 5. Is this the question 5 you're referring to? So if this is a perfect square, okay, so it's not a perfect square. Okay, but all you're doing is you're breaking this into factors. so that way you can reduce the root as much as possible. Find the 4s, the 9s, all of that kind of stuff. Here, if I have 17,496, this is divisible by 4. Pull out another 4, I cannot. I can pull out a 9. I can pull out another 9. Another 9. Okay. So basically, if you take your calculator and you do 4 times 9 times 9 times 9 times 6, you get 17,496. Anything that's a perfect square can come out as its square root. So 4 comes out as 2, 9 comes out as 3, 9 comes out as 3, 9 comes out as 3, and 6 has to stay. So if I put all these together, I get 54, which you can do on your calculator, root of 6. How do you figure that out? Basically, you just start guessing. It's like a guess and check kind of thing, because you're looking for anything that's perfectly square rootable. So you're looking for factors of 4, 9, 16, 25. So you just divide it by 4. Doesn't work, try 9. 9 doesn't work, try 16. So you're looking for those factors. 6 stays because 6 can't be perfectly square rooted. So it just stays under the root. So it can be broken into a 2 and a 3, but neither one of those can be perfectly square rooted either. So if it can't come out as a perfect number, it has to stay. Okay, so I have 2 more questions to go over. Question yes. 9 times 0 is 0. 1 to the 0 is just 1, because anything to the power of 0 is 1. So I have 13 and 10 on the radical page. Right here. Remember with exponents, if it's even, I can take it out. What I'm going to do is I'm going to split this into even. I have a 4 and a 1, that will give me my 5. 3 to the 6 and 3 to the 1, that gives me my 7. 4 to the 4. 2 to the 4, I just divide this by 2. It comes out as 2 to the 2. The 6, I divide the exponent by 2, becomes 3 to the 3. 4 to the 4, I divide the exponent by 2, it becomes 4 to the 2. I'm left with a 2 and a 3. You could do this on your calculator, but you don't have to. Sometimes you'll get a number so big it won't fit on your calculator anyway, so you can just leave it like that. Okay. Last but not least, number 13. How did I do that? Have the rule, remember that anytime you have an even exponent here, out, what this root means is divided by 2. And all I do is take the exponent and divide it by 2 to take it out. Now we've been doing this with variables, but we can do the same thing with numbers. It doesn't really matter. So the exponents are exponents. So as soon as you have an even exponent, it comes out, and I just divide the exponent by 2. So I did that here. I separated it into an even with an odd, even with an odd, and since it's even, I didn't touch it. All right. Last but not least, number 13. In this case, you're multiplying. Do the coefficients times the coefficient times 16 under one bracket. So x, the y, and the z. 5 times 16 gives me 80. Look to see if there's anything I can take out under here. I'm done. This is my answer. Okay. $19? Sure. All right, we'll take this one last question and then we're going to have to move on. So what I'm going to do here is you have two different ways that you can handle this, okay? Just put one big bracket and then deal with it, and then deal with it, and that's what we're going to do, okay? So one big bracket. So we reduce the numbers. So 125 and 900 reduces to 5/36. So we're going to have this here. X to the 10 and x to the 5. So we have 10 minus 5 gives me x to the 5. Y to the 6 and y to the 3 gives me y to the 3 because we do 6 minus 3. The 12 and z to the 5 give me z to the 7 at the bottom. The same thing. I want to pull out what I can pull out. So 5, I have x to the 4 and an x, y to the 2 and a y, 6, z to the 6 and z to the 1. So out of this bracket, the x to the 4 comes as x to the 2, y to the 2 comes as 1, the 36 comes out as a 6 because 36 is 6. The z to the 6 comes out as z to the 3. What's left under the bracket are x, y, and z. So when you're dividing, you subtract the exponents. Make your life easier. So another way to do this, when you have z to the 5 and z to the 12. In theory, you should be doing 5 minus 12, putting it on the top, which is negative 7. Flip it to the bottom anyway, to give you the positive 7. So a quick way to do dealing with exponents like this, you do big minus little. So 12 is big, the little is 5. So you do 12 minus 5, which is 7. It goes in the same position as the bigger one. So this goes in with the bottom because 12 is at the bottom. All right. Just as a side note here, where did I get the 6? The square root of 36. Square root of 36 here, 6. It came out of the bracket as a 6 because I square rooted it to get it out of the bracket. Oh, that was my mistake. Good catch. 5 stays in right here. Good catch. Thank you very much. All right. You know, this morning you might have seen, you might not have had a chance to look at it. You have the handout solutions. I've done every problem with all of the work. So it's a bit clearer, easier to handle. So you can take a look at this too, and then go from there. I have the assignment answers, okay? So everything's going to be posted there on Google Classroom. All righty. Oops. We have done online issues, assignment questions, questions about homework, time for a new material. So we are almost done with radicals. We talked about multiplying, dividing, simplifying. So we have two things left to do. We're going to do both of them today. So I'll give you a chance to write these notes down, and then we'll take a look at some examples. Okay, so adding and subtracting. So just like with polynomials and monomials, when you're adding and subtracting, you can only add or subtract like terms. So when you're talking about polynomials here, you're looking at the variables and the exponents. C, identical. In this case, because it was identical with the 10, we just add the coefficients because they're identical. So I have 3 of something and 10 of that something. For total, I have 13 somethings. So if it's apples or oranges, it really doesn't matter. The point is we have 3 somethings and 10 somethings, so we have 13 somethings. But in this case, even though we have an x squared, we have an x in all of the terms, because the exponents are different, they're identical things. This is like saying I have apples, oranges, and pears. So let's say certain number of those things because they're not the same things. So it's the same thing with radicals. The problem is sometimes it will appear that they're not the same. When you manipulate them, when you simplify them, they actually are. Okay? So you're going to simplify them so the roots are the same. Roots are the same, you add, subtract the coefficients. So take a look at those examples. On the next page, the first thing you do, I'm back. Are we ready to go now? Okay. Fantastic. So here we go. So what we are looking for here is to see if the radicals are the same. In this case, we have the root of 14 and the root of 14. They're identical. So all we do is we do 6 plus 7. 6 plus 7 is 13. Do I have 13 of? I have 13 of root 14. That's it. That's all. Here, yeah. So I have root m and I have root m, meaning I have the same radical. So I just take the coefficients and I put them together. So ignore this completely. 5 minus 23, negative 18. So I have negative 18 of root m. The problem happens when you have a problem like this. When you first look at it, you're like, okay, well, the bases aren't the same, the radicands aren't the same, so nothing I can do. But that's not true. Because, excuse me, here, it can be reduced and simplified. So before you make a decision whether or not you can add them, you have to simplify all of the radicands. So 25 can be written as 5 and 25. "25" we square root it, so it comes out 5. This little 5 is left under the root. You can put these together to give you 20. Because 4 times 5 is 20. Now, all of a sudden we have the same root. What do? Numbers, and I put them together. It's an adding. 27 root of 5. So always reduce the radicand first, and then decide if you can add, subtract, multiply, divide, do whatever you have to do. I'm going to let you try letter F on your own, and then we'll take a look at it together. Okay, let's take a quick look at this together. So, first glance, you're like, well, these aren't the same. But you know better. You try to reduce them. X cubed can be written as x and x squared. 2 can be written as 4 and 2. Once again, you get that by testing it. Saying, see if you can put a 4. If you can, then do it. So what can be pulled out of this one? Well, the 2 can't, the x can't, this can. So we get 8x squared gets pulled out as an x. We are left with 2x under. What can be pulled out of this one? This gets pulled out as a 2. This gets pulled out as a 2. This gets pulled out as x squared. And you're left with 2x under the root. So let's simplify this just to put it together, make it look nicer. 8x squared And here I get 3 times 2 times 2 is 12. Our radicals are identical. I'm just going to take these, I'm going to put them together. Now the little trick here is that in order to be able to add or subtract those things, because they're variables as well, you have to check them out. Well, I have x squared, I have x squared, I'm good to go. So 8 minus 12 is 4. And that's it. Questions? We'll do one more together quickly and then we'll move on. Any preferences, G or H? Speak up, type, anything, preferences? I have one of each. Anyone care to be the tiebreaker? H? All right. Sure, no problem. Slow down a bit. Great. 7x. So, is everyone muted? Because if the audio is cutting in and out, it might be because someone else is not muted. So just take the time quickly, make sure you're all muted. To answer your question about negative 4x with 2x to the 3 rooted, that's not simplified because you can separate x to the 3. An x squared can come out. Okay, so that's not, your radical is not completely simplified. So it worked to add this stuff together, but then you would still have to pull that out. Okay, one last one here, we'll do H. So once again, this, not so good. So we'll separate it. 99 can be divided by 9. And we're left with an 11. X3 separates into x and x1. Y6 is even, so it's good to go. Six separates into 11 and 16. X to the 4 and x to the 1. Now we're seeing what we can take out. 9 comes out as a 3. Squared comes out as an x. Y6 comes out as y to the 3. And we're left with 11 and x in the bracket. Sixteen comes out as 4. 4 comes out as x to the 2. We're left with 11x in the bracket. Put this all together. I get 21x squared y cubed. X. And I get 16x squared y cubed. These are the same. I can add these up. So 21x squared y cubed plus 16x squared y cubed. Now all I do here is check them again. We're good to go. 7x squared y cubed root of 11x. Now in all of our examples, we were able to add them up. Okay? have something like this, 12x 2x plus because you have something like this. This doesn't match this. You're done. This is done. Nothing more you can do, okay? In this case, that would be done. So just be aware that if your radicands don't match exactly, that you can't do anything else. Is that far enough up? Perfect. So there's just one more thing left for us to do with radicals. Two different cases that we have to deal with differently, but only one thing left to do, and then we're done with radicals, which is very exciting. Please, please, please don't get discouraged. Radicals is one of the harder things that we're going to cover together over the 3 weeks. Are we good to go? Awesome. So, I'll let you copy that down. Okay, so with exponents, like we saw, it is improper to have a negative exponent as a final answer. So if you have a negative exponent, you have to take care of it, or your answer's not, you're not going to earn full marks for your answer. With radicals, we have the same type of idea, but it's not the same thing. So with radicals, it is improper to have a radical in the denominator. So if you have something like this, you're not done. This is not something that you can have. This is not a proper final answer. So what we call rationalizing the denominator is when we're getting rid of the root in the denominator. So you have 2 different cases of this. A single radical is something like this, where you have something in the bottom and that's it. So we're going to use the idea. If you remember when you add and subtract fractions and you needed a common denominator, what you did was, if you had 1 over 4 and you needed to put this on something 16, you multiplied by 4 top and bottom. Doing that, you're changing the appearance of the fraction, not the value of the fraction. So we're going to use this idea with radicals. Okay, so here's what we are going to do. We are going to multiply top and bottom by the exact same value. So we have the root of 5. We're going to multiply top and bottom by the root of 5. Because if I'm multiplying top and bottom by the same thing, I'm not changing the value, I'm changing the appearance. Now I'm going to show you a couple of middle steps here, but you don't actually have to do them. Okay? So 3 root 5 goes together. Under 1 root, 5 times 5. We see that when we have these numbers under a root, pulled out as a single number. That's the root of 25. This gives you. So if you type this into your calculator and this into your calculator, you're going to get the same numerical value, but one of them is a proper answer and one of them is not a proper answer. So So we're using this idea that if I multiply the square root of something, it gives me that number or just that variable. So this is the principle we're going to be using for this case and for the other case. Every time if you want to, you can go through this step, through this step, through this step. Or you can just say, okay, well, I have the root of 5, the root of 5. No, that's 5. Because the root of something times itself just gives me the number or the variable. So it's up to you. Excuse me. Here's the same idea. I have the root of 7. Deal with the 3, not really. If I include the 3, I'm just going to have to reduce later, and I'm trying to minimize the steps that I want to minimize. I want to minimize the steps that I want to do, that way I have less work. So 2 root 7 just becomes 2 root 7. We have this 3 that just exists. We're going to use the principle that root 7 times root 7 just gives me 7. I put them together, 2 root 7 divided by 21. So like I said, you want to go through all the steps, be my guest, I will correct them, but if you want to save yourself some time, don't bother. We're gonna do D, but I'm gonna change this to an X. So you have a square root button on your calculator. So the question is, what button do we press to solve it? So you have a square root button on your calculator. So if you type in 2 square root 7 divided by 21, you'll get 0.251976. And if you type in 2 divided by, with a bracket, 3 root 7, you'll get the same thing. So we've just changed the appearance, but we're rationalizing it to give it a proper answer. All right, so here, same thing. I just changed this to an X. I'm going to change this to an X. So we have an idea of how it works with variables. Okay, so it's no different with a variable. Same idea. I have root X on the bottom. I'm going to multiply by root X and root X. The only thing is when you have a binomial here, you have to multiply each term of the binomial by the term here, okay? Minus root X times root X. With distributes, we have that distributive property that you see when you're multiplying. Goes to root X times root X plus X. 1 times anything is just that something. Root X times root X. So we can X again. And we have an X here. So like I said, this exact value as this. However, one is rationalized, meaning it's an acceptable answer, and one is not an acceptable answer because there's a root at the bottom. Okay. The second case scenario is if you have a binomial at the bottom. So we'll take a look at what this looks like. I'll give you a minute to write this down, and then we'll do some problems. Okay. Whoops. Okay. So rationalizing, if you haven't gotten it, don't worry, we're going down. Here. Case 2, a binomial denominator. So if you have something that looks like this as your denominator, you have 2 over plus 1. You cannot use the other method, because if you use the other method, you're just going to keep creating radicals over and over and over and over, and you're never going to be able to rationalize the denominator. What we are going to use is something called the conjugate. Binomial that signs between the terms. So if one is an addition, the other is a subtraction, and vice versa. So 1, the conjugate of that would be same as the x is 1. Instead of a plus, we have a minus. Same thing here, we have the 2x, and a plus, a minus. 3x minus 5, the conjugate of that would be 3x. If I have the root of x plus 1, the conjugate of that, do you have your, is everybody having that problem where the audio is cutting in and out? Okay. My internet, that's possible. I'm at the school, so hopefully the school's internet wouldn't be the problem, but you never know. I'll try to go slow just to make sure that we're not missing anything, okay? If it gets really bad at some point, let me know. I'm going to try to do my best from my end with the lagging and the cutting in and out. Just make sure that your volumes are on full blast, and hopefully that will help things a little bit. And I'll send an email to the tech people to let them know that we're having this problem, and hopefully we can find a way to fix it, okay? So here the conjugate of this would be root of x, 1, but instead of the plus, we have a minus. So we're going to multiply, in order to rationalize the denominator, when it is a binomial, to multiply top and bottom conjugate of the denominator. We want to rationalize this. What is the conjugate of this? Well, I have root of 5, 1, but it's going to be a plus. Do the same thing on the top. Everybody gets a bracket. What happens here is this root of 3 distributes to both. So when I have root of 3 times root of 5 plus root of 3 times 1. Now again, I'm going to show you every step to this part of it, but you don't have to do every step when you get used to it. So because you have this, do each term of the first times each term of the second. So it's like binomial, it's foiling, so binomial multiplication. We're going to look at that when we do a review of polynomials a bit later. Each term of the first times each term of the second. As we said before, root of 5 times root of 5 is 5. Then I do the first term times the second here. Plus 1 root 5, which is just root 5. Once I've done that, I take every term and multiply by every term in the second polynomial. So negative 1 times root 5 gives me negative root 5. Negative 1 times 1 is negative 1. What happens here is if I'm adding something and subtracting it, it cancels out. If I give you $2 and I take away $2 from you at the same time, you're not any different than what you were. Nothing has changed. Zero. You have a net change of 0. So here, the fraction is I'm doing this multiplication, okay? So I'm taking each term, since it's a binomial, I'm taking each term, so we'll maybe write it out here. I take each term of the first times each second terms, okay? So I start off with this times this, which gives me this times this, which gives me positive root of 5. This times this, which gives me negative root of 5. And finally, this times this, which gives me minus 1. So that's just what we have here. This stuff together, here's the root of 15. The root of 3 times 1 is just the root of 3. I end up with 5 minus 1 because the middle two things cancel out. So the root of 15 plus the root of 3 divided by 4. We're done. These two things go together as we don't have the same radical, and they can't be forced to be the same radical either. We're going to do E. No, you can't go any further with it because you can't divide these. This doesn't have a root to it. There's nothing you can do with the 15. There's nothing you can do with the 3. So this would be your final answer. That's it. That's all. Let's take a look at E. Now, E is the same thing. Doesn't matter if you have a variable at the bottom. Makes no difference. Your steps are the same. Multiply by the conjugate. So I have the root of x. I'm going to have minus 4. And the root of x, that's a 5, not an x. Louise. Root of x minus 4. Everybody gets a bracket, so we remember how to multiply this properly. So 5 multiplies by root of x to give me 5 root x. 5 multiplies by negative 4 to give me minus 20. Now we're going to work with the bottom. Root of x just gives me x. Root of x times negative 4 gives me negative 4 root x. 4 and root x gives me positive 4 root x. And 4 times negative 4 gives me minus 16. Here in the middle, I'm subtracting something and I'm adding something, so I'm not doing anything. What am I left with on the bottom? X minus 16. You're done. There's nothing more you can do. Now, what you might notice is every time you're doing this, you see here, I want a nice pink color here. What we get on the bottom here is this one squared, which just becomes x, minus this one times this one. You get x minus 16. If you look up here, the same thing happened. We got On the bottom, 5, minus 1 times 1, which is 1. So that's not a coincidence. That's not on purpose. If you've done a few of these, you might feel comfortable enough to just jump from this step to this step. Okay. You have to be comfortable with it. If you do this middle step, by all means, please do. We're going to do one last one. Multiply by the conjugate. So underneath, we're going to have 2x plus 3. And on the top, 2x plus 3. Everybody gets a bracket. On the top, unfortunately for us, or fortunately, whatever, you actually have to do the foiling. So I'm going to have this one times this one. So x root of 2x. This one times this one plus 3. This one times this one minus root of 2x. This one and this one minus 3. Now, like I said, if you're comfortable enough, you can just say, well, the root of 2x times the root of 2x is just going to give me 2x. 3 and 3 is 9. Yes. That's what we got here. That's what we got in the other one. That's what we're going to get every time. If you're not comfortable doing it or you're not 100% sure, by all means, do the full steps. But you'll see, if we do the full steps, we get this times this to this times, not that one, times this is 3 root 2x. Then I do this one times this one, negative 3 root 2x. And finally, this one and this one, which is just negative 9. Okay? And you see here, I'm adding something, I'm subtracting something, it goes away. So if you're comfortable enough just making the jump, straight to this, you can. Any questions? All right, if there are no questions, I feel like there's no better. I agree. I think that it's easier to do it the fast way because it's less work to do. But like I said, it's all about your comfort level. So in theory, if you have, what is that? So if I give you this, okay. And tell you to rationalize it. A lot faster. Okay, so here we're going to multiply by the conjugate. On the top, you still have to FOIL. Okay, so I do this. So underneath here, you'll get the root of 5 times 6x will give you 30x. And 5 times the root of 5 times 1 is just 5. But then you skip down. Okay, you literally just say, right here. We literally just say, this times this, well, it's 6x. What is 1 times 1? 1, and it's going to be a minus. You're done. Okay? So I recommend, highly recommend doing it this way. Some people won't be comfortable with it. That's fine. But if you are, it just saves you a whole bunch of time and a lot of less confusing routes. So feel free to just jump right to that, and this is your answer, and you're good to go. Okay? Any other questions? It would not be 6 times 6. What ends up happening when you do root of 6x times root of 6x? What ends up happening is you'll get 6 times 6x squared. 36x squared. Now both of these come out. 36 comes out as a 6, x squared comes out as an x. Cancels right out. Okay? How can this math be incorporated into a word problem? Chances are, I can't guarantee it because I have like no control, no idea, but chances are if you get a radical problem, you'll get it in a part A or part B because it doesn't integrate well into a word problem at all. So it's more just like straight math kind of doing things, okay? You would not lose marks for not showing work. If you show this, enough work to get marks, okay? Like I said, if you get this problem in a part A or part B, no one's looking at your work. So you wouldn't lose marks. If you did happen to get this in a part C because they decided to somehow incorporate it into a part C, showing this here, this step into this, more than enough work. Because everyone knows why we do this, just be able to jump to here. So no problem at all, okay? Fantastic. So you can take a deep breath or a breath of relief because we're done with radicals. That was probably one of the most heavy part of what we're going to be looking at together. I don't want to say hardest because hard and easy are relative to you, but it's one of the more dense things that we cover in this course, okay, or in this bridge course. So what we're going to do today, we're going to continue. We're going to jump into a review of polynomials. We're a little bit behind, so this review of polynomials, we're going to blitz it out like nobody's business. Because all of this stuff you should have done throughout this year and through secondary 3. So this should really, really be a really quick, really, I don't know, basic review. So here we go. Polynomial review, here's the blue to write down. Okay, so I just got 2 questions, so while you're copying it down, I'll answer both of them. The notes and definitions, so you have the blank copy, and it's my expectation that you're copying the missing stuff down. If you don't catch it for some reason, you can go onto my YouTube channel. I'll send the link in Google Classroom, but all of these Hangouts are completely recorded. So if for some reason you miss a part or it cuts out or you absolutely need a snack in that minute, you miss 2 minutes, everything is uploaded onto my YouTube channel. So from the start of this till the end of this, recorded completely. So if you miss anything, that's what it is. I got a question about the fraction button on the calculator. I'm looking for a button that looks like this. Okay? If you're not sure if your calculator has it, send me a picture of your calculator. Someone did that yesterday, no problem. And I'll just circle it, show you where it is, and then we can talk about how to use it. Okay? Cool. All right. So, quick review. The blank notes are posted on Google Classroom. So just to clarify your question here, on Classroom, got the class 2 notes. So this is what your notes look like. Notice there's no blue. These would be classified as the blank notes, okay? So basically what I post is everything that we do without the blue. So anything that's written in blue, you have to copy down. These are on Google Classroom. So while we're doing this, that's why I posted the day before, so you could print them out, figure out how you want to do it. Copy the blue stuff down. So look, this is the page that we're on right now. This is what yours looks like. This is what mine looks like. So you're filling in the stuff that's missing. Okay. And then if you happen to miss something for whatever reason, you can go back on the YouTube channel and check it out because everything will be there. Or you can send me an email. Feel free to send me an email at any time and I can just like take a picture of what you're missing. I'll fill it in for you or anything. Okay. So just a quick review. Terms are combinations of coefficients, variables, and exponents. So when you've got 2x to the 5, you've got a coefficient of 2, an exponent of 5, and a variable of x. A specific term, a monomial, is a product of an integer and a variable. So these things are monomials on their own. The degree of a monomial is the sum of the exponents on the variables. Okay, so for degree, we take the exponent. This has a degree of 12. We have different variables with different exponents, but since they're all stuck together, we add them. 2 plus 3 plus 5 gives me 10. One same thing, a little 1 here that we cannot forget about. 5 plus 1, a degree of 6. So just as you're copying the last couple of notes, polynomial, as we know, is a sum of monomials. So we take a whole bunch of them and we add them together, subtract them, and we call this a polynomial. So we've got the first term, the second term, the third term, fourth term, 10th term. Doesn't matter how many terms, it's a polynomial. Specific cases of polynomials: monomial, binomial, trinomial. So monomial is 1. Binomial is 2 terms added or subtracted together. Binomial bicycle, 2. Trinomial, 3. So 3 terms added together. The degree of a polynomial is a little bit different. So in order to find the degree of the polynomial, it is the degree of the highest term. So I look at each of the terms. So this is a term on its own, degree of 7. This is a term on its own, it has a degree of 5. Term on its own, it has a degree of 4. This is a term on its own, it has a degree of 2. What is the biggest number I have? 7. So the degree of polynomial is 7. So we do not add them up. We do each of these terms individually. But in this case, we've got the 9 and the 4. 13 for this term. I've got the 6 and the 2. That gives me 8 this term. I've got the 5 and the 2. That gives me 7 for that term. Biggest number, 13. Degree is 13. So far, so good? Fantastic. Any objections to me going to the next page? So, operations on polynomials. We're first going to talk about addition and subtraction, then we're going to talk about multiplication, and we'll finish off with division. So, operations on polynomials, adding, subtracting, we just talked about this. You can only add or subtract like terms, which has the exact same combination of variables and exponents. For instance, with number 1, you need to, so we have x to the 2 and y to the 5. X to the 2 and the 5. We have identical combinations. 1 here, I have 3 here, so I have 4 of them. In this case, I have a to the 3, a to the 4. They're not the same. Exactly nothing. So it just stays like this. Because they're not like terms, nothing I can do. In example 3, what I'm going to do is distribute this negative in and open the brackets up. So I have 4x squared minus 8x plus 1 minus 2x squared plus 6x minus, why did I say 6x? Oh my goodness. Plus 3x minus 5. I add my like terms. So this is an x squared, this one is an x squared, so 4 minus 2 gives me 2x squared. And they're gone because I've used them. This is an x term, this is an x term. Negative 8 plus 3 minus 5. Gone. Term, this is a number term, 1 minus 5 minus 4. Done. And we're done. Any objections to going to the next page? Cool. Great. All right, going back. Fabulous. So we are now going to be doing multiplication. So here, each term gets multiplied. 5x, 12x squared gives me 60x cubed. 5x times negative 7x gives me negative 35x squared. 5x times 3 gives me 15x. We just did a lot of this with the conjugates. So I'll do just this one quickly. We have a binomial by a binomial. It's each term times each term. So 9x times 7x squared is 63x. 1 is 9x. 3x times 7x, 21x. And negative 1 is negative 3. And then we put our middle term together. So we get 6x squared, 12x minus 3. I did that in the last class too. I don't know why. It's like I forgot it's 63 and not 6. I mean, I forgot it was 63 and I just put a 6. Thank you. Twice. All ready to go. FOIL, absolutely. FOIL is just a way to remember how to do it. So 1. I just did. All right, whatever. FOIL means first, outer, inner, last. So first means the first times the first. Outer means, whoa, means the outer one times the outer one. Inner means inner one times inner one. And the last means the last times the last. It's just a way to remember each of the different terms when you're multiplying like that. All right, division. So one quick problem with division by monomial, and then we'll move on to division. There we go. Okay, when you are dividing by a monomial, I'm blitzing this up very quickly, I know, but this should be old news. When you're dividing by a monomial, divide each term by the monomial. So we take each term and divide by the monomial. So 20x5 divided by 2x gives me 10, because 20 divided by 2 is 10. x5 divided by x2, x3. The second term, 100x4 by 2x squared gives me 50x squared. Green. Term 3. Here's 12x cubed divided by 2x squared gives me negative 6x. Last but not least, final term. Divided by 8x squared divided by 2x squared gives me 4. And we're done. That's monomial division. So you just take each term and divide by the divisor. That's it. That's all. All right, this is where the new material comes in, okay? So this should have been reviewed. We just really needed this foundation. I needed to make sure everyone was on the same page as I am. This is where the new material comes in. And let me tell you, it's important. Okay, so let's take a look at this together. So don't panic. I know we have only about 10 minutes left. So I'm going to go over this. We'll do maybe 1 or 2 examples together, and then tomorrow during the first hour we're just going to blitz out example, 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 example to make sure you're comfortable with this. Okay? The sessions upload to YouTube as soon as I hit stop broadcast. So like a minute. When we're done, I hit stop broadcast so it stops projecting and then uploads to YouTube instantaneously. So right after the class at like 12:21. It doesn't, I don't know if it streams on YouTube. That's a very good question. It may stream on YouTube as well. The only thing is on YouTube, it's not as interactive. You can ask me the questions and stuff like that, but the whole video is definitely uploaded to YouTube right after. What's way harder? This, it's not harder. There are just more steps to it. And this is likely, these type of things come up a lot, okay? In different types of questions. So we want to make sure that we have a really, really good handle on this. It's not way harder. It's just more in depth, more steps. So when you're dividing a polynomial by a binomial, just in terms of, we're going to be using these terminologies, so make sure you know what we're dividing is the dividend. Here, what doing the dividing is the divisor. And the quotient is here. So you're going to be following the same steps. Of the dividend, divisor. be your answer. This answer, and you multiply these terms under here, and start again. If you take 2 minutes to, on the side or whatever, try to remember how to do long division with numbers. It's the same steps. So it's just that we're doing it with polynomials, and all of a sudden it gets a little bit more intimidating. So we're just going to do one example together just to get your brains kind of in gear what I mean, and then I'll explain what we'll be doing tomorrow, okay? Here we go. Whenever you see this, you have to write this as a long division. Here, 5x minus 7. Have 5x squared plus 3x minus 14. Okay. Steps are the same. You take this by this. Squared divided by 5x is just x. It up with my x term. Multiply the x by each of these terms. It gives me 5x squared minus 7x, and I subtract. Absolutely, I will return to the last page. While I'm explaining what we're doing for work and stuff, I'll go to the last page again. So 5 minus 5 is cancel out. 3 minus negative 7 gives me 10. My next number. 10. 10x divided by 5x gives me 2. 5x gives me 10x. 2 times negative 7 gives me negative 14. I'm going to be subtracting. X minus 10x goes away. Negative 14 minus negative 14 goes away. And I get my answer is 0. Or my remainder is 0. Sorry, this is my answer, x plus 2. So basically, we follow all the same steps as long division. The numbers at the top, okay? So this number, we started here, 5x squared divided by 5x gave me an x. Then I took this one, 10x squared, x, divided by 5x, give me 2. It is Euclidean. It is. That's exactly what it is. Euclidean division. So, like I said, you're going to blitz out so many of these that you'll just, hopefully we'll get to the same page. We'll do so many different examples for like the first 45 minutes, hour tomorrow. Just while I'm explaining, I'll go to the last page just so, here we go. It's a little small, eh? All right, so here's what the plan is for tomorrow. First of all, the work planned for you for today, a lot of it is this division. When you'd stop in terms of a remainder. We'll go over the remainder tomorrow, okay? So you stop, just so you know, you stop when you get a term that has a smaller degree than your divisor. Which sounds complicated, but it's not. If you have an x, you stop when you get a number. If you have x squared, you stop when you get an x. Stop when you can't divide anymore. We'll look at a couple of examples of those tomorrow because sometimes you do get a remainder, and we'll look at that. So some of the work that I had planned for you for today, a lot of it's long division. So don't do those questions. There are some of the ones that you can do. So on the handout for today, that will be released any minute. But I'll just show it to you now. I don't know. It'll be released soon. Okay. case, just do the problems that you can do and don't touch the long division ones. You can just add those on for tomorrow. And in the assignment, there are some long division problems, so just leave those on the side and we'll tackle those tomorrow, so don't worry about that. So do what you can on that handout that will be uploaded this afternoon, probably around or maybe in the next 15 minutes. But don't worry about the long division stuff, we'll cover that tomorrow. Tomorrow, you're to be in school for my class. If you have a morning class, that's your morning class. You come to class, they'll let you know what classroom you're in. That's it, that's all. So bring the notes that we did today, and I'm gonna post the notes for tomorrow this afternoon. So print both of those out and bring them for tomorrow. Okay, and then we'll go over the notes and do some problems and all of that kind of stuff. Pencil, paper, calculator, you guys know how to be prepared for a math class. Link to my YouTube, I will post that on the Google Classroom this afternoon, so you can go and check out the videos. If you have any questions between now and then, feel free to send me an email or post on Google Classroom. Okay? Any last minute questions? Fantastic. Have a great afternoon. Looking forward to meeting you tomorrow.